Hey, you're back. It's time for lesson 43, simplifying rational expressions. 43 is prime number. Pay attention to that. 43 is one of my favorite numbers. All right, so back to defining our language. I like doing that. We get that word rational. In math, it does not mean that it makes sense. There are a lot of things in math that don't make sense. But it comes from here, ratio. Remember back when we were defining our different sets of numbers, rational numbers are any numbers that can be written as a fraction of whole numbers. So rational means that we're dealing with fractions. That's all that it means. And in our title today, it said rational expressions, and that just means that there are no equal signs. It'll just be a little problem there without an equal sign that we either are going to simplify or we're going to evaluate. We're going to think about it a little bit. We're going to determine what we're allowed to do with it and what we're not allowed to do with it, but it's going to be some sort of fraction. And then, of course, since this is algebra, there's going to be some letters, some variables that are in there that we could plug in any number that we want to and see what happens with that. One of our first problems that we have with rational expressions is that sometimes when we put in a variable, it makes it so that we end up with cases where we're trying to divide by 0, and we just can't do that in math. We can have something like this, and as long as this number down here, represented by x, is not 0, then we will get an answer. So that's okay. As long as x isn't 0, then we're good. We could play around. But if we've got some number and we're trying to end up dividing by x, well, that's bad. That's bad. And that results in a thing called a null set. Or, better way of describing it would be saying that it is undefined. Math does not have a definition for a number divided by 0. You can divide by a very, very small thing like 0.00000001 and still get something, actually get a very large number. But the smaller that fraction gets or that decimal gets in the denominator, the closer and closer the whole expression gets to infinity. So when you actually get to 0, you're at infinity, which you can't actually ever do in math. So there are good reasons why we don't divide by 0. Another reason is that a wormhole will open in the earth and it will swallow you and your family whole. So you don't want that to happen either. I've seen it on the internet, so it must be true. Okay, so we're going to play around first with that idea that we don't want to end up dividing by 0. And so sometimes with an expression, our first job is to determine what values of x are going to cause that case to occur. So we got to put on our thinking cap. The longer that we do algebra, the more creative we have to be, the more imagination that we have to have. We're already dealing with something abstract. I want to know what x is, and they're not going to tell me. But we have to look at just the denominator here. Remember, this is the numerator up here, the sum x plus 8. And the denominator down here, that's really what we're interested in evaluating. Because again, it's the denominator, if that equals 0, then we have a problem. So what we need to do in these types of problems is just take that out all by itself and imagine what value for x would it have to be for this equation to equal 0, for this expression to equal 0. Okay? So you can use our basic math, and we could just divide both sides by 0. 0 divided by 4 is 0. So if x equals 0, then that leads to a situation where the original thing is undefined. You pick any other number to plug in there. If you plug in negative 20, you'll get something out of this. If you plug in 400, if you plug in 2.2, you'll get an answer to this to this expression up here. But if you plug in 0 there and there, then it's undefined. I don't even really care what happens on the top, because the top can equal 0, and that's fine. It's only if the bottom part, the denominator, equals 0 that we run into a problem. And we need to know what to call that. So we call that being undefined, or we can use the null set. There are no answers that satisfy. If 0 is the thing, then that does not satisfy that expression. It won't make any sense. So there's one example. Here's another one. X minus 4. Okay, so we don't care about what's going on the top. It can be whatever it wants to be, but in the bottom, here's what we're looking for. When is that true? What value of x will make this thing equal 0? We're just going to use our plus 4s on both sides and find out that when x is 4, this thing won't work. So we plug in a 4 here, we plug in a 4 here, the top becomes 9, but the bottom becomes 0, and that is undefined. So there we go. That's our first goal, is to find the values for x that we're not allowed to use. It would cause us to be trying to divide by 0, and thus we get a situation where it's undefined. Sometimes it's a little bit hard to tell at first what that might be, and actually in some cases there's some simplification or some factoring that you can do to work things out, massage the problem a little bit. So here's an example where they actually encourage you, I think I'm missing something, x, where the top part is actually factorable. It can be simplified a little bit, and sometimes that helps us check something, and sometimes it doesn't. But I can see here that both the 54 and the 9 are divisible by 9. So I'm going to divide both of those. I'm going to factor out a 9 out of the top. 9 times 6 is 54. Okay, and actually this is probably a preferred expression because we have factors. We have the factor 9 and we have the factor 6x plus 1. And that's multiplication. So if something can be eliminated, it's a better way of doing it. But this doesn't factor out at all. And so that just was simplification to help us see if there was anything there, and there wasn't anything exciting there. So we can just take that 4 plus x and evaluate that and see what x would have to be for the denominator to equal 0. 4 and negative 4 would equal 0, so negative 4 would be an excluded value, or we'd say when x is 4, negative 4, then this expression is undefined. Undefined. Okay, so that one wasn't terribly exciting, but the next one is something that you will see in math problems, even way up into calculus. You do see things where it's much better to sort things out first and then see if there's anything that can cancel out. Now this problem has some x squareds in there. Okay? I can't just cancel those x squareds out because in the numerator that is part of a sum, and in the denominator it's also part of a sum. And so I'm gonna factor these out and see if there's anything in common, top and bottom, that I can eliminate or I can cancel out that equals 1, and then see what's left over. So looking at the top, I got a greatest common factor of 2 and x. And if I factor out the 2 and the x out of this one, I'm left with x. If I factor out 2 and an x out of this one, I'm left with 5. And I can see down here that I also have 2x that each of these is divisible by. And that leaves me with 2x and 3. So the factor 2x is in both the numerator and the denominator. Those can be canceled out. And then my expression just turns into, it's simplified down to this right here. I'm going to only care about the denominator and evaluate that and say when would this equal 0, and do the math on that one. That 2x equals negative 3, and then divide both sides by 2. So when x is, divide by 2, negative 3 over 2, that makes the expression undefined. Now, the curious thing about this is that that is true, but there was another value for the original problem that would also make it undefined. So the original problem was right here. And the trick was right at this stage where we cancel things out to simplify. The simplification helps us find maybe the harder one to pick out. But there's another one that's still true because 2 times x, if x is 0, 2 times 0 is 0, and 0 times this would equal 0. So a second value for us for the original equation would be when x equals 0. So just think about it. Plug in a 0 here, go 0 squared, 0, times 4 is 0, plus 6 times 0, that's 0 plus 0 is 0. And that would make this undefined because it would give you a denominator of 0. So this one actually has two answers that cause this thing to be undefined. And that makes sense because the problem started off with x squared. So there's up to 2 different answers that would cause this thing to be considered undefined. All right, there's just one more example. Let me clear my board and we'll talk you through that one. Okay, it's word problem time. And the category, I guess, for today is moving objects. Okay, in their expression, in their example, they explain about the movement of an object or the acceleration of a moving object in respect to time. So we start a stopwatch and things already moving, crosses the start line, and then it starts to speed up. This might be an expression. T is standing here now for time, which is a very common thing in the physical sciences, like physics when we're measuring the motion of objects. So imagine this is a race car with a rolling start, hits the start line, and then it speeds up even more than it's going. It's going about 3.5 meters per second, or whatever the case may be, and then it starts to accelerate, like your mom does when she gets on the freeway. They're going to compare that to if something starts from rest. It pulls up to the starting line, like the stop sign or the stoplight, and then the light changes and it accelerates, and then saying what that would be like if it accelerates at twice of that rate of acceleration. Twice the rate of acceleration here of 0.7 is 1.4 t squared. So they just gave us a problem and said, let's work with those details and see if we can find out when this thing is undefined. Let's see if we can simplify it at all. It gives you a couple of things to do with it. Okay, so I can see right away you got 3.5 and a 0.7 and a 1.4. Those all sound like things related to sevens, right? Okay, you know your 7 multiplication tables, 1 times 7, 2 times 7, 5 times 7. There's some 0.7 business here that can be pulled out first. And I see that every single term in this expression has a t in it. So I'm going to factor out 0.7 and a t out of the top. And that leaves me with 5. And over here, that leaves me with t. And then denominator, if I pull out the 0.7 and the t, it leaves me with, that's 2. T. So if I stop right here and I look at all the things that might make the denominator 0, I can tell pretty quickly, since it's just a number times t, if t equals 0, this expression doesn't make any sense. So I'm going to put here that t cannot be 0. That would make this undefined. Does it make sense? If you are haven't even started the stopwatch yet, how can you measure the distance that something travels? Because it hasn't gone anywhere yet. Okay, if I want to simplify this then down to a simpler equation without squaring stuff, I can just cancel these out and be left with the expression 5 plus t over 2t. And I can't do anything else with that, so I stop. And there you go. There would be your expression. It's still true here that if t equals 0, that this expression is undefined. 5 plus 0 is 5, but 2 times 0 is 0. And so the problem makes absolutely no sense when time equals 0. So there's just a practical application problem. Hope that helps. We'll talk to you later.